Okay, today we are looking at statistics or data handling, and I'm just going to revise some of the grade 11 work with you guys. Last week you did the grade 12 data, so this week we are jumping back and we are going to look at the things that we had to do in grade 11 again. Okay, so I'm going to start with what we call the measures of central tendency, and you guys have been doing some of these since grade 8 or grade 9. The easy three is what we call the minimum, the median, and the maximum of the data. So for that, the minimum value will be the smallest value, the maximum value will be the biggest value, and the median will be the value in the middle of the data. Very important for this. Remember, your data has to be organized from smallest to largest. So if I have a data set, I can't simply say the first number is the minimum. I have to make sure that the data is organized from the smallest to the largest. Then the smallest one will be the minimum, the biggest one will be the maximum, and the one in the middle will be the median. So from the median, we actually lead into the lower quartile and the upper quartile. So I'm just going to write down a data set here so that you guys can just get an idea of what we are working with. Like that. So that is an organized data set. So from this, I can easily identify the minimum value will be 1. And then I'm going to leave these out first so that they are in the right order. The maximum value will be 11 because that's the biggest value. And then for the median value, we say we have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data. So the middle value will be the 5th value. Now in this case, it happens to actually be 5. But I'm not looking at 5th value, so I'm looking for 5. I'm saying there's 1, 2, 3, 4 pieces of data on the left-hand side. 1, 2, 3, 4 pieces of data on the right-hand side. In other words, the 5 is the value that divides this into 2 equal parts. So that will be my median. And that we did previously in grade 8 and grade 9 stats. But now for the Q1 and Q2, we are going to divide it into quarters. That's where the word quartile comes from. So the median is actually sometimes referred to as Q2, meaning that if you have 2 quarters of something, you have the midpoint, which is the median. So if I look at this data set on the left-hand side, this part, I'm now going to go further and divide that into 2 equal parts. So we have 4 pieces of data there. In other words, my Q1 value will be halfway between 2 and 3. So remember, if it's not a specific value, you can just say it's the midpoint of those 2 values, which is 3 in this case. And then if I look on the other side, then this part will also be divided into 2 equal parts, which will be there. So I'm going to say it's 7 plus 10 divided by 2, and 17 divided by 2 is a fraction, but you can just write it as that. Okay, then very important when we're working with the range, we say it's just the maximum value minus the minimum value. So in this case, the range would have been 11 minus 1. And the interquartile range will be Q3 minus Q2. So in this case, it'll be 17 over 2 minus 3, which is 11 over 2 or 5.5. It doesn't matter. Okay, and also know that the range is an indication of how widely spread all of the different data can be. And while if you're looking at the interquartile range, it actually gives you an indication of how close to the median all of the data is. So if the interquartile range is very small, it means that the 50% of the data between Q1 and Q3 is actually relatively close to the midpoint of the data. Okay, then when we look at a box and whisker diagram, now how did we jump to a box and whisker diagram? The box and whisker diagram is just the graphic representation of the 5-number summary. So what we do is we go and we put our minimum value and our maximum value at the 2 points, and then your other 3 you have to mark there, and you draw a box over Q1 to Q3, and then it has its whiskers stretching out to the minimum value on the left and the maximum value on the right. Very important for when you are drawing a box and whisker diagram. These days they actually normally give you a number line, but if they don't, remember it has to be a number line and it has to be to scale. Why am I saying that? So you can't draw a numbers line and say it's 1, 2, 10, 45, and 50, because these jumps are equal distances from one another, but the values are not equal numbers from one another, so it has to be to scale. Okay, then also when you're drawing this, please indicate which values represent your minimum, your lower quartile, your median, your upper quartile, and your maximum value. Then when we're looking at the distribution of this data, when we're talking about skew to the left, you're actually looking for your box lying on the right hand side. Symmetrical means it's more or less in the middle, and skew to the right is when you are looking for your box lying on the left hand side. So it's a bit counterintuitive. If the box is on the left hand side like we have here, then it means you write down it is skewed to the right. Okay, I'm gonna stop this video now and then first attempt to do number 1.1 and 1.2, and then I'm going to start a new video to do the mean and the standard deviation, and then we can get to 1.3 and 1.4.